Hi everyone, this lesson is about integration by substitution, and we use this technique when we are faced with integrals that have the form we have a function of another function, so f of g of x, a composite function, and then as part of the original integrand we have multiplied by the derivative of the embedded function g of x. So the clue is, if we can see part of what we're dealing with and its derivative or a multiple of its derivative exists, then this is the technique to try. This will be clearer, I think, with a few examples. So let's sort of keep that in the back of our mind as we try the first example. Now, for instance, what if we had the integral of sine x multiplied by cosine to the fifth power of x dx. Now, we won't be able to use our trig identity substitution because although there's a product of sine and cosine, we've got this extra powers of cosine here to deal with. But I do note that the derivative of cosine is negative sine, so it's a multiple, -1 multiplied by sine. That gives me a clue. So I will say let u equal cosine of x. And then cosine of x is like the embedded function, and the power of 5 is I suppose the algebraic function raising to a power of 5. And what are we raising? We're raising cosine of x, which is the embedded function inside the algebraic function. So now what we do is we take the derivative du dx, and we know that that's negative sine of x, and we rearrange this until we have dx isolated. So du divided by the negative sine of x gives dx. Now we're ready to substitute. We've got cosine x, which we'll substitute as u, and because we've changed our variable to u, we'll have to change our infinitesimal dx to this expression involving du. So let's see how that works. All of that, I might just move that off to the side. Let's just put that over there. So still important, but perhaps off to one side makes it easier. So our integral then, sine of x is still there. Instead of writing cosine of x to the power 5, I'll write u to the power 5, because u was after all cosine x. And instead of dx, I'll write du over negative sine x. Now this is why it was important that the derivative appeared in the original integrand. So we can cancel them out, and that effectively cancels out the variable x as well, which means we have now a pretty straightforward integral to worry about. It's negative u to the power 5, should have had integral negative u to the power 5 du. So what do? Well, the power increases to 6 and we divide by the new power and we add a constant of integration. And lastly, we would replace, we would write it back in the original form. Remember that u was cosine of x, so that is cosine to the 6th power over 6 plus our constant of integration. That's our integral, and we did it by choosing a suitable substitute. The trick is choosing the substitute. If we had chosen u equals sine of x, we would have got bogged down and got nowhere. And if that happens, just go back and try again with a different substitute. Let's have a look at a second one. So that first one was involving trig. Let's do a purely algebraic one this time. So what if we had the integral of x plus 3 multiplied by the square root of x squared plus 6x minus 8 dx. So we're looking for part of this to substitute. And with the thing that we want to choose something whose derivative appears there. Well, I think I'll choose the quadratic expression here. Derivative of this would be 2x plus 6, which is a multiple of this other term we have at the front here. So let's see how we go with that. We'll make the quadratic, not the radical sign, just the embedded function. X squared plus 6x minus 8. Take the derivative. Du dx is 2x plus 6. Remember, we hope to see this or a multiple of this appear, and we do. In fact, I might think of this as 2 factored outside x plus 3 to make it very clear that the x plus 3 is part of that. Remember, we want to isolate dx. So divide by 2 by x plus 3. That would be dx. I'm now ready to substitute. I have a substitute for my quadratic, that'll become u, and I have a substitute for the infinitesimal dx. So let's do those substitutions. I still have x plus 3, and then I have u for the quadratic. I might put power of a half instead of a radical sign, and then instead of dx, I have du over 2 times x plus 3. Now you'll know that it's working at this stage if the other part of the expression that contained the variable x cancels out. If that doesn't happen, you've probably chosen the wrong substitute, and it's probably worth going back and having a second try. So I have this factor of a half, and then I have the integral of u to the power half du. That's a pretty straightforward integral. So increase this power by 1 becomes 3 over 2. Divide by the new power of 3 over 2 and add a constant of integration. So I have 1 half. Divide by 3 over 2 is the same as multiply by 2 over 3. That's straightforward. Then u was my quadratic expression, wasn't it? Oh, it's still a bit messy. I'll just leave it as u at the moment. 3 over 2 plus c. Now I'll write the thing neatly. My quadratic was x squared plus 6x minus 8. Check that. I remembered that. Yes, I did. That's all to the power of 3 over 2. And all of this is divided by 3 plus a constant of integration. If we're quick, I think we have time for just one more. And let's do one involving, let's go 5x. Now what about e to the power of 3x squared minus 1 dx? Remember, we're looking for a substitution, so let u equal. Now, I can see that this expression 3x squared minus 1, the derivative would be 6x. That's a multiple of this. That looks like it might work. So let's try 3x squared minus 1 as our substitute. Take the derivative. Du dx equals 6x. Isolate dx. So du over 6x equals dx. We're now ready to do the substitutions and hopefully get something much easier to work with. So the 5 times x is still there. E is still there, but this time it's e to the power of u. Dx is being replaced with du over 6x. Now there's what we wanted. The variable x cancels very nicely, and I would have, if I take the constant 5 over 6 to the front of my integral, I have e to the u du. What could be easier? So 5 over 6 e to the u is the integral of e to the u plus the constant of integration. Now let's replace u with the original expression 3x squared minus 1. So 3x squared minus minus 1, that's all divided by 6 plus the constant of integration. So there we go, that's a short little lesson on integration by substitution method. As you see, it can work with exponential terms, it can work with algebraic terms like this second one that we tried, and it can work with trigonometric terms. The key to it is to find part of the original integrand and its derivative exists there as well. So remember, if the first thing you try leads down a dead end, go back and try a different substitution and see how that goes. Okay, that's enough. See you next time.